Cool, thanks. First of all, I'll apologize for the amount of gradients in this presentation. Peter and I synced up earlier. He went with the orange into red gradient. I've kind of gone with this magenta into yellow. I'm going to be talking about synthetic testing using Swift. Bit of a disclaimer, I'm going to be talking about server-side Swift rather than iOS development, just so you know. I'm an engineering manager at a company called GoCity. When I started at GoCity, just for your knowledge, I manage an app development team. And one of the things I wanted to make sure was that we didn't have much context switching, so that we only used Swift and only used Kotlin in our development within that team. But we had to build backend services. So one of the things I was interested in knowing was whether server-side Swift was production ready. So how would I go about finding that out? Well, one of the things I did initially was I built a little prototype. So I built this little colleague recognition app. The idea was you got a bunch of little post-it notes. You could kind of go on there, give recognition to a colleague, say, nice job, you did this great thing. All the post-it notes would be color-coded according to the company values. So there'd be a little icon in each corner and a different color for each post-it, sort of according to which color company value you pick. So we've kind of got things like we are a team or we lead with data. So these are the values at our company. So I did that. It worked pretty well. Figured that this is working okay. Wrote that using Vapor, one of the most popular server-side Swift frameworks. And then I thought, is that enough? Well, no, not really, because aside from just knowing whether you can build some sort of application, you need to know, are there libraries for interacting with Kafka? Are there libraries for doing a bunch of other things? But one of the main things I needed to know was, could I implement observability? So observability is something that most of you will have in your iOS apps already. So, you know, if you've got something like Firebase, a cheeky little reference to our hosts in your app, then that will provide you some level of observability of your application. You'll find out whether your app is crashing for users. So in a server-side context, and just so you know, there's more than just Vapor out there. There are different Swift server-side frameworks in existence. So there's Smoke by Amazon. The first three are written in Swift NIO, which is an Apple framework. And then Flying Fox is a sort of newer contender written in Swift concurrency. I was looking at observability, and the main things that people think about when they're talking about observability are logging, metrics, and tracing. So basically, I was on a fact-finding mission to find out, could I get these things into my server-side application? And the answer was yes. It turns out I was actually pleasantly surprised because for each one of these things, Apple had already written a framework for me. Bear in mind, this is going back 3.5 years ago as well. So at the time, I was trying to research whether server-side Swift was ready for production. And I already found that Apple had thought of all of these things for me. I was actually surprised that they'd invested so much time into creating all these frameworks that I could sort of pick up and run with. So aside from having a framework for logging, metrics, and tracing, they also had a bunch of other frameworks that I've included just down here, which you might want to use if you ever decide to write a server-side Swift application yourself. Maybe you are in an apps team and you have the need to roll your own backend service. Some of these things may be useful to you. So I'll talk very briefly about a couple of these, starting with logging. So the interesting thing about the way the Swift log framework, the Swift metrics framework, and the Swift distributed tracing framework all work is they essentially provide you with essentially an API for interacting with logging, an API for interacting with metrics, and for distributed tracing, but not necessarily the implementation. So the idea is you have this interface and you then plug in your implementation into that. I'll tell you a little bit about what I mean in a minute. So going into Swift log, essentially, the way you interact with that in your server-side application is pretty much always the same. You're always interacting with a logger. You have a log level. So in this instance, I am logging at the info log level, and I'm just logging a simple hello world message. None of this will come as a surprise to you. You're probably quite used to using loggers in this way. But the nice thing about this particular framework is you can then plug in a back-end implementation, and for instance, you can send your logs to Datadog, you can send your logs to Discord, or you can send your logs to Google Cloud. Another cheeky Google reference for you there. And the nice thing is the way that you send your logs to these different implementations is always the same. So how does that work? Very quickly, the way that works in Swift Log is you implement a log handler. The default one that you get out of the box is the stream log handler, essentially just kind of logs to your console. If you want to bootstrap that, this is how you essentially tell the Swift Log framework that this is the concrete implementation that I'm going to use. So you'd actually bootstrap the implementation, and then from then on in your application, that is the log handler that will get used by the logger. If you are using Vapor as your server-side framework of choice, there's a little framework called ConsoleKit, which is the one that's used as default. If you ever kind of create a brand new Vapor project out of the box, if you go on the Vapor website, there's a little bit of a Vapor init command, which will kind of generate a template project for you. This little bit in green towards the bottom is part of that project. Essentially, it kind of bootstraps the ConsoleKit logger for you, and from then on, that is the logger that will be used. It just has a little bit of customization so that it will log at a certain level when you're debugging, and then when you're in prod for efficiency reasons, it will log less, essentially. For my use case, we use something called Kibana at our company for logging. So across all of our microservices, we use something called ECS logging. So ECS logging is a particular type of logging called structured logging. And essentially, the way that is implemented is it uses a JSON format. So in this JSON format, you can kind of see that the structure of the logs is always the same. You always get the timestamp first, you always get the log level, and then the message. And that way, the logs always look consistent. They're very easy to read. Even though they're JSON, you can read them as a human. But more importantly than that, they're very parsable on the back end. So your logs always come through in a very consumable format. You can kind of filter on them, do all the kind of nice stuff. You don't have to do any kind of grok transformations to get your logs into the right format so that they're searchable on the back end. Because they're JSON, because you're using a standardized set of field names, you've always got the right information right there, searchable and queryable. Cool. So this little framework that I wrote is compatible with the Swift Log framework. In fact, if you go on the Swift Log repo on GitHub, you'll find a link to it there. It also works with Vapor and supports custom events as well. So if you don't want to use one of the out-of-the-box fields, so the nice thing about the ECS log format is it defines a whole bunch of fields that you can use, but you can also kind of create your own events as well if you want to log very specific things that are specific to your company or your use case. That is possible too. It's got the option to fall back to non-JSON in non-prod environments. So if you kind of just want in your Xcode terminal to get a more typical textual kind of log, and then when you deploy to the server, then have it use JSON, that's something you can do. Just a little kind of side note, because I kind of thought it was cool. One of the log fields in the ECS format is this error.stacktrace kind of field. So that will be part of the JSON. And the nice thing about that is, just very quickly talking about backtracing, if you're a Java developer, you'll be used to something like this. When a prom goes, when something happens in your application, it blows up, you'll get a stack trace telling you these are the lines of the code where the problem occurred. In Swift 5.9, there's now an out-of-process interactive crash handler, but even cooler than that, you can programmatically access the stack trace. So as part of that logging, if you log an error in your server-side application, you can now actually get the full stack trace as part of your logs, which I thought was quite cool. Coming back to observability, so I talked about logging. I'll very, very quickly talk about metrics, and the reason why I'll talk about metrics is because it's quite important to the synthetic testing that I'm going to talk about later on. So the metrics package works in a very similar kind of way. Essentially, it provides you with an API, so no matter what backend you choose to use, whether you choose to use Prometheus or StatsD, etc., you're always going to interact with it in the same sort of way. So essentially, the metrics package provides you with counters, gauges, meters, recorders, and timers. So essentially, these kind of things let you send metrics to a backend about things like the number of 200 responses your server returned, or the number of 500 responses your server returned, or if you're talking about maybe a meter or recorder, you might be talking about the size of the requests that were coming into your server, or the amount of time it took for you to serve a response. These are all the kind of metrics that you might be looking at when you deploy a server-side application. You want to kind of monitor it. You want to make sure it's not returning too many 400s or 500s. This is a useful package for doing that kind of thing. Cool. So at our company, we use Prometheus. And Prometheus looks a little bit like this. So if you've got a Vapor application, essentially what you can do is you can provide an endpoint which will serve up all of your metrics. And the way that Prometheus works is that Prometheus will poll your application and this specific endpoint that you provide every so often, and you kind of specify the interval at which it does that. It will then kind of keep hold of all that data for you, and then later on that data will be queryable. You can alert on it. You can present it in a Grafana dashboard. So there's a ton of stuff you can do with this data once you've got it. The other really nice thing that I'll just mention very quickly is that in Vapor, because they don't need to know about the specific implementation, so they don't need to know about Prometheus, they don't need to know about statsd, etc. They only need to know about Swift metrics. The cool thing is they have already integrated Swift metrics into Prometheus, into Vapor. And because they've done that, there's a bunch of out-of-the-box metrics that you can use right away. And I find that really cool. So, in order to get this stuff working, I actually used a framework called Swift Prometheus. Again, it was another package that was out there, open source. I could take it and run with it. Not Apple this time. There's actually a group called the Server-Side Swift Working Group, and they provide a bunch of open source packages that you can use as well. If you go on the swift.org website, there's a link to that working group as well. Just so you know what that endpoint looks like. So I was kind of talking about an endpoint that Prometheus would hit every so often. It looks like this. This is the smallest text in my slide deck, I promise you. I know it's a bit of an optician's test, but hopefully you can vaguely read it. So essentially you can kind of see the sort of quantiles of like response times that you get there. You can kind of see how many sort of 200s you're getting roughly and how many 400s you're getting roughly. I took this based on real data, and then I just kind of sabotaged it a little bit just to not to give any sort of company information away, but this is vaguely real. So in addition to logging metrics and tracing, which people would probably consider the core of observability, it's also useful to consider these other two things, real user monitoring and synthetic testing as well. So real user monitoring, probably something like Firebase, where you're kind of looking at how often is your application crashing for users, how fast is your UI responding, that kind of thing. So essentially real user monitoring is kind of a reactive tool because the crash has already happened by the time you found out about it. You're finding about, like a lag in response times after a user has already experienced that problem. But what if there was a proactive way that we could find out about this stuff? And just so you know, what I'm definitely not saying is don't use real user monitoring because it is reactive and use synthetic testing because it's proactive. Definitely use both. All I'm saying is that I'm just going to focus on the latter for the purposes of this talk. But in real life, you want to make sure you have both in your application. So, synthetic testing. I'm going to talk very quickly about shift left and shift right testing. So shift left testing. How many people have heard of shift left and shift right testing? A few hands. OK, cool. So shift left testing is about testing as early as possible in the development process. It might not always be the things that you think. For example, our design team like to test a problem, they validate a problem, and they like to validate a solution before they go away and produce designs. So they might generate some wireframes, they might go and speak to some customers, and all of that happens before a line of code has ever been written, because we know that as we go through the software development lifecycle, the cost of making a mistake gets higher and higher and higher. If you write some code and you put it in front of users and it doesn't work, it's unintuitive, what have you, you have to go back to the drawing board and build it again. Very expensive to get some developers to do that. So you want to catch problems as soon as you possibly can in the lifecycle. Some more traditional examples of shift-left testing would be the things that you're used to, like unit testing, integration testing, UI testing, snapshot testing. We do all of these things at our company. We even do contract testing, which is testing the contract between our iOS app and our APIs. So we use something called Pact for that. Essentially, what happens is a contract gets published to a repository, and then the iOS app and the server-side application need to sort of ensure that they are fulfilling their contract once new versions are published. That way, we try to make sure that one doesn't break the other, essentially. Onto shift right. So that's more about testing after the development has been done. So essentially what we're talking about there is testing the quality and performance of the application under real-world conditions, so essentially in the production environment. Examples of that would be A/B testing. I'm sure a lot of you have used A/B testing with something like Firebase or what have you. Putting out canary releases, blue-green releases, and of course, synthetic testing that I'm about to talk about now. There's lots of different types of synthetic testing. So it might be testing the availability of your API. So you just want to call your API, check that it's serving you a 200, it's doing the thing that it ought to do. Or you might be checking that it returns the right kind of response that you expect it to. You might be more interested in looking at the performance of that API. How quickly is it serving response? Is it serving response to users in Australia as quickly as it is to users in the UK, for example, things like that. And transaction monitoring, this is a particularly important one for our company because we sell things, so we have a checkout process, and we want to make sure that we can run synthetic tests that pretend to be a user going through the checkout flow and to make sure that they can purchase something. So one of the things that's particularly interesting about synthetic testing is, I mentioned it's proactive. So if you have these tests and let's say they run at 2 a.m. or whatever time where you're unlikely to have many customers using your website, if the problem occurs at that time, you're still going to find out about it because your synthetic tests are going to be running, let's say, every 5 minutes, every 10 minutes, even at 2 a.m. When those tests fail, you'll get an alert about it, a PagerDuty, however it works at your company. An engineer will be told about that, they'll be able to wake up, they'll be able to fix the problem. You don't have to wait for your real user monitoring to go off and for a company to, for a user to actually have experienced the problem before you know about it. Cool. So I kind of briefly covered the reasons why you might want to use synthetic testing. Now I'm going to talk specifically about how you can implement synthetic testing. So we use Kubernetes at GoCity. So Kubernetes is something that was actually invented at Google, so it feels very topical. KuberHealthy itself is a Kubernetes operator for synthetic monitoring and continuous process verification. So that is a bit of a mouthful. So essentially what that means is that KuberHealthy is something that extends Kubernetes. So Kubernetes is something that is extensible. It defines the concept of resources. So in Kubernetes terminology, you have things like pods. Pods are basically where your code executes. You have things like persistent volumes, so a place where you can kind of store your persistent data. Think of it like a hard disk, essentially. So those are all resources in Kubernetes terminology. And essentially what KubeHealthy does is it provides a service to receive the status of your synthetic checks. So it will get the results of your synthetic tests, and then it will expose those results to Prometheus, which is why I was telling you about Swift metrics and Prometheus earlier on, so you can kind of see where this is all kind of hooking together. So KubeHealthy is something that's part of the Cloud Native Computing Foundation, which is a project to kind of bring together a bunch of technologies like these, like Argo, Helm, Jaeger, Kubernetes, and Prometheus. If you haven't heard of some of these, you might be interested to know that things like Jaeger are used for distributed tracing. So I talked about the Swift distributed tracing framework earlier on. Many people use distributed tracing here? No? Oh, maybe one person. Okay, go one person over there. So distributed tracing is essentially if your company uses microservices. Let's say, for example, we have a checkout and we have a web checkout. In order to place an order, you have to call our order service, you have to call the payment service, and those services in turn will call other services. If a problem occurs, you essentially want to know whereabout in the chain that problem has occurred. So essentially, the way that the error will manifest to the user is in the UI, in the checkout, you'll just say an error has occurred. But as a developer, that's not very useful. You want to know specifically, was it in microservice 1, microservice 2, etc. Distributed tracing allows you to follow the request all the way through from the UI to the lowest layer of the microservice, shall we say, and all the way back through the response. So you will be able to pinpoint specifically in which microservice your problem occurred. So Jaeger is a sort of concrete implementation of distributed tracing. And I've kind of talked a little bit about Kubernetes, and I've talked about Prometheus. So what KubeHealthy lets you do is it lets you write your tests in any programming language, and then KubeHealthy will run them for you. And a little useful thing to know is that KubeHealthy provides a bunch of checks for you out of the box. If you are using Kubernetes, it will provide checks like telling you whether your pod is restarting excessively. Maybe there's a problem and that problem causes it to restart continuously. Or it will provide you with an HTTP check to check that your URL endpoint serves 200s. Common things that you might want to do. So I kind of talked about it being a Kubernetes operator, essentially a fancy way of saying that it allows you to extend Kubernetes. I talked about resources being pods, persistent volumes, etc. And also the nice thing about KubeHealthy and being an operator able to extend Kubernetes is that you can kind of create these custom resource definitions. So things like these. So the custom resource definitions in KubeHealthy are things like a KH check, which is essentially a check that gets conducted periodically. So in our case, what we're going to do is we're going to run our synthetic tests every 15 minutes, every 5 minutes, however often is appropriate. There's also a KH job, which is kind of the same thing, except it only runs once. And then we also have this concept of a KH state, and that is essentially going to be the result of your synthetic tests returned to you. So whether they passed, whether they failed, if they failed, what errors were flagged up. So they say that a picture is worth 1,000 words. So here's a picture to explain what that means. So essentially, KubeHealthy lives in this box here, brought to you in the miracle of C4 diagrams. Essentially, what it's going to do is periodically it's going to use the Kubernetes scheduler to run your synthetic tests. So your synthetic tests are going to run. They are going to run against your API. So this is your sort of vapor service over here, if you will. Your synthetic tests will call that API. The results will be reported back to KubeHealthy. And they are in JSON format. And then essentially, this is now kind of fitting together with what we talked about with Swift metrics earlier on, because now Prometheus is going to essentially scrape KubeHealthy and pull all your metrics together. So I also quickly talked about the CRDs, the custom resource definitions. So this bit here, where KubeHealthy is periodically running your tests, that's the KH check. And when the results of the tests get returned, that is the KH state. I'll show you an example of what that really looks like in a moment. So what does it take to get this set up if you're trying to do this yourself? So first of all, you're going to install KubeHealthy in your Kubernetes cluster. I've kind of grayed that out. I'm not going to talk about that too much because there's instructions on how to do that in the KubeHealthy repo. But if you have any questions about this, we can chat about it in the pub or what have you. Most companies probably have a platform team that will set this stuff up for you. Second step is you want to define your KH check or your KH job, specifying what tests you're going to execute. I'll show you an example in a second. You want to have some kind of test runner. So essentially, when we deploy our synthetic tests, we package all our test runner, our synthetic tests up in a Docker file. We deploy them into the cluster, and they run. So as part of that, you're going to write your synthetic tests, and they're going to perform kind of smoke tests against your API. So just so you know, when you're writing synthetic tests, you're not trying to run your whole suite of unit tests or what have you against your Vapor application. That's not the point of them. The point of them is to sort of provide more of a kind of smoke test that, yes, my app is still running in the production environment. It's still returning the response code it's supposed to. You're still getting back vaguely the right information. It can do more complicated things than that. It can kind of go through your checkout flow and make sure that it's still possible to add to basket, to place an order, that kind of stuff that's really important to your company making money. That's how we use it. And then the last step is you're probably going to deploy all of this stuff as part of your CI pipeline. So we use Circle CI, we build our Docker image, and then later on, when we're running our synthetic tests, the Kubernetes scheduler is going to pull the Docker image, deploy it to a pod, the tests are going to run, the results will get returned to KubeHealthy, and Prometheus will scrape those results, and then Bob's your uncle, you'll be able to do something with those metrics, and I'll talk about that later. So I promised to show you a very quick example of a KH check. So here's a very quick example. It's in the form of a config map, which most things are, to do with Kubernetes. The important parts are, you've kind of got the name of your check, you've got the run interval, so in this case, it's going to run every 15 minutes. It will time out after 5, and you tell it kind of where your Docker image is that you want it to pull and run, essentially. So KubeHealthy clients, so you need to be able to run your tests and report your results back to KubeHealthy. So KubeHealthy, like Kubernetes, is written in Go. And what that means is that if you use a client library to speak to KubeHealthy, you can use the client that is available in Go. They also provide a client for JavaScript, and you can get that through NPM. And they also provide a Python client for you to use as well. So that's nice, but when I was looking at this a long time ago, I looked at the part that said you can write your tests in any language, and that made me think, oh, well, maybe I can write my tests in Swift in that case. So what I did is I wrote a little library called Swift KubeHealthy. There is a little package up on that GitHub repo just now. I'll be publishing the full 1.0 version in a few days' time. Essentially what it comprises is a test runner, which accepts a command to execute. So what I'd suggest you do if you decide to use this is put together a Xcode package, put together a package.swift, and essentially build a test target. And then from the command line, you can run the Swift test command, and it will execute all your tests and collect the results, and then it will package them and send them off to KubeHealthy for you. So there's two parts to this. There's the test runner, and then there's the part that actually communicates the results back to KubeHealthy. It looks something like this. So you've got your Kubernetes scheduler, which will periodically pull your image. So this is the whole Docker image here, essentially. Within that, you've got your test runner. So the entry point to the Docker image will execute the test runner. The test runner will run your synthetic tests. And your synthetic tests, if you're writing them in Swift, which hopefully you would be, can use XE-test, or you can even use the new Swift testing library, which I'll talk about very, very quickly. Your synthetic tests can run against your Vapor API. The results will be collected back by the test runner, and then the KubeHealthy client will actually report these results back to KubeHealthy, which Prometheus will consume. Okay, so in terms of reporting the results back, you're probably wondering what that looks like. I mentioned a KH status, which is the results of your call. Essentially, it's actually a lot easier and less complicated than it looks. There's two things. There's the OK value, which is a bool. True if your tests pass OK, which you'd hope they would most of the time, because that means there's no problem with your system. False if there is an error. If there is an error, this array will contain strings denoting what error occurred, essentially. Whereas if this is true and your tests have succeeded, this array will be empty. In terms of actually writing your synthetic tests, you can use the XE-test framework. I've put a very trivial example here. So this one essentially just calls a API that I made up, checks that the status code is 200. You wouldn't do this in real life because, as I mentioned earlier on, KubeHealthy provides a lot of out-of-the-box checks for you. One of them is a check that will check that your API is returning 200. But you can do what you like here, essentially. You can check that your response body contains the right stuff. You can even make it really complicated. You can call several APIs in a chain, like adding a product to a basket, passing that basket to your order API, whatever you want to do. You can kind of write it in your tests here. So you can use XE-test to do that. If you're using Vapor, you'll probably be using a framework called XET Vapor, which builds upon that, which provides extensions for making HTTP requests and inserting on the responses. This example doesn't make use of that, just so you know. But just so you know, they do exist. You can even use the Swift testing framework, which I've been dabbling with a little bit recently. If you want to do that, you need to use Swift 6, so you'll be using the Xcode 16 beta. It's a cross-platform framework, so it'll still work on Linux and what have you. I've kind of highlighted with beautiful gradients the differences in the code here. So you'll be using the test macros, the require, and expect, rather than the XET assert equals that you might be used to in the past. Small differences to do the same sort of thing. And then, once you've got all of that working, so your results are going to be reported back to KubeHealthy, what you can do is that you can actually go onto your Kubernetes cluster. There will be a pod running in your cluster called KubeHealthy. And if you port forward to that, there'll be an endpoint, a JSON endpoint that looks like this. And you'll be able to see the results of all of your KubeHealthy tests reported in that endpoint. And this little bit here will be particularly familiar to you because that's your KH state, essentially. That's your bit that's telling you whether your tests executed successfully in this case and there were no errors, or, as it might happen, maybe your tests failed and then you'll find out why your test failed. This is quite customizable, and unfortunately this is a real example, so someone didn't provide some great information there. What can you do with that stuff? So essentially, once your data is into KubeHealthy and thus into Prometheus, you can then use something like Alert Manager to set up alerts, which will tell your developers that something's gone wrong with your system. You can take your Prometheus data, you can display it on a Grafana dashboard. If you want to show it around your office and show, oh look, the synthetic tests are failing now, we need to do something about that, you can. In fact, you can even have your Alert Manager hooked up to your Slack instance, which is what we do. We have it hooked up to our PagerDuty, so if a lot of these alerts are going off, then somebody will get woken up at 2 a.m. and have to do something about them if it's a severe problem. So just to summarize, I talked about observability. I wanted to know whether Swift on the server was ready for production. We saw a bunch of frameworks that did provide observability, so it seems like it is. Our company's been using Swift on the server for 3.5 years. It's been working pretty well for us. I mentioned that out of logging, metrics, distributed tracing, real user monitoring, synthetic testing is a useful tool to have as part of your observability suite. We use Kuberhealthy and Prometheus. That's one specific way that you can implement synthetic testing. There's clients for Kuberhealthy in Go, JavaScript, Python, and now Swift, thanks to the Swift Kuberhealthy library. You can write your tests in any language, but I showed you some examples, particularly in Swift. And I showed you what you could do with synthetic testing. You can kind of set up your alerts in Alert Manager, or you can display that data in Grafana. And that was a bit of a whirlwind tour, but I hope it was useful.